Good afternoon, students. Good afternoon to one and all. Today class we will know about the engineering mechanics. I think all of you know about the engineering mechanics. Engineering mechanics is the one of the main basic for civil engineer. Had to know each and every topic of engineering mechanics, starting from the whether it what is meant by first engineering mechanics, how it will be coming from the engineering mechanics. Here, what is how it is divided from the engineering physics. We will see one by one in today class. For your gate classes and for your competitive examinations, it is very useful. From engineering mechanics itself, we will get 20 marks for your group one. There is a three groups will be there for gate. Engineering mechanics, strength of materials, structural analysis will be in one category, and then fluid mechanics, water resources will get in the second category, and the geotechnical engineering, transportation engineering, water resources engineering will be come under third category. These are all main different categories, and then different groups. Based on these groups, they will divide it the marks according to the engineering mechanics. This is the first 20 marks. We had to learn about the engineering mechanics. From this, already all of you know about the engineering mechanics. According to our government has gave us one chance for each and every engineering college. We had to give the implementation for the Preerana gate classes for all the students who are studying in BTech classes in our colleges. It will be very useful for you. You can know about the engineering mechanics according to our subject. The main engineering mechanics introduction is nothing but it is the branch of the physical science. Physical science already we learn from the starting from the first standard onwards. From first standard, second standard onwards, first we will learn about the English, and then first language, second language, mathematical and physics. Similarly, from that stage onwards, we are learning about the physics. It is the engineering mechanics is also one of the branch of that physics only. Okay, here the branch of the physical science that deals with the state of whether the body is in a state of rest or the body is in a state of motion, that we had to observe here, and then that observation and that term is called as the mechanics here. Okay, whether a body or a material which will be in the state of rest or which will be in the state of motion is termed as a mechanics. Okay, this is the first term we had to learn from the physical science. Okay, from physical science, that is nothing but if you observe in physical science, starting from your 8th standard and 9th standard, how we learn in that itself, we learned about the acceleration. The next, what is meant by Newton's law, and then we had to learn about the friction. That all will become in this engineering mechanics. Okay, the main application of laws of mechanics to field the problems is termed as the engineering mechanics. What are the problems that we had to observe in the field? That all the application of laws of mechanics to field problems is termed as the engineering mechanics here. Here, basically, the engineering mechanics divided into two groups. First one is mechanics of solids. Another one is the mechanics of fluids. Okay, mechanics is nothing but the whether the body or a material is in a state of rest or is in a state of motion. Okay, based on that category, again we are dividing into two types. This one will be one will be for solid condition. Another one will be for the fluid condition. Okay, mechanics of solids. Another one will be mechanics of fluids. Okay. Now we'll see the bodies which will not deform or the body in which deformation can be neglected in the analysis are called the rigid bodies. Whether if suppose we are taking one brick, for that brick we can't observe any deformation. We will see directly the brittle nature, and then suddenly the cracking will be we observed. Without observing that, there will be some deformations will be there, but which can be neglected in the analysis. That type of the bodies will call as the rigid bodies. Okay, the mechanics of rigid bodies dealing with the bodies at at rest is termed as the statics. Whatever the bodies we are mechanism we are seeing, that type of mechanism, whether it is in a state of rest, that type of the body will called as a statics. And the dealing with the bodies which will be in motion, that is a moving always in moving position, that conditions will call as a dynamics. Okay, the dynamics again it will deals with the dynamics. It is dealing with the problems without referring to the forces. that causes the motion of the body is termed as the kinetics. Suppose the body which will be deals with the force that causes by the motion, then it is called as a kinetics. Kinematics and kinetics, there is a two differences are there in dynamics. First of all, again we'll see the main body live diagram of this engineering mechanics I will show. Okay, next, the internal stresses that will be developed in the body or studied in the deformation, that should not be considered here. That type of fluid mechanics is called as the mechanics of the deformable bodies. That will be, we have to learn in strength of materials and solid mechanics. Now we'll see the second one. This one is the main diagram that we had to learn in our engineering mechanics. Engineering mechanics, already in the first introduction we told that there is a two types will be there, mechanics of solids and mechanics of fluids. This mechanics of solids is again two types, whether the body is in a state of rest or the body is in a state of motion. Based on that condition, we had to divide it the two types. That will be mechanics of rigid bodies, that is the rest bodies. Another one is the mechanics of the deformable bodies, that is the body which is in moving. That we have the body which will be the elastical and plastically deformable, that we will observe here in the mechanics of deformable bodies. Here, if you observe in our category, in our BTech level for our GATE exams, we had to know about the mechanics of rigid bodies only. In MTech level, they will be, you can learn about the mechanics of the deformable bodies. That will be whether the body will be in a plastic state or in an elasticity state. That we had to learn the theory of elasticity and theory of plasticity in MTech level. These two parts. But here, according to our GATE and according to our any competitive exams, we had to know about these topics, mechanics of the rigid bodies. Okay, these mechanics of rigid bodies is again divided into two types. Already we know that state one is a rest position, another one is a moving position. Whether that is in a rest position, that is a statics. Whether it is in a moving position, that is a dynamics. In moving position also, if suppose we are applying some force, based on the force it is moving, it is a kinematics. Without any force, that is a kinetics. Here you can observe with the force causing the motion, some force which we are observing, some force which we are causing the force, that is kind of called as a kinetics. The force is causing the motion of the body without any referring any force, that will be referred as a kinematics. Okay, without any referring of the forces, the body is moving means that means kinematics. Some force we are applying, based on that force, the body is in moving position, then it is called as the kinetics. These are all the two types of the dynamics are there. This is the main free body diagram for the engineering mechanics. Again, you can know about this all we learned in starting from the engineering mechanics, strength of materials, and then structural analysis. We learned these all conditions. If you go for the mechanics of fluids, here again the fluid, based on the fluid also we can learn the mechanism. Here in this mechanism, there will be ideal fluid, there will be a viscous fluid, and then there will be incompressible fluid. We will see one by one. These all will be, we can learn in the fluid mechanics. This is one of the main topic. Ideal fluid is nothing but it is a constant fluid. This will be, the number will be 1 like that. We can see mechanics of fluids here, this topic. Okay. In engineering mechanics, we learned about the mechanics of the solids and then rigid bodies, whether it will be a static condition or it is a dynamic condition. In dynamic condition, again, it will be based on the force or without force, referring with force and referring without force, that we'll observe here. Without force is the kinematics, with force is the kinetics. Okay, this is the main difference. They will ask for a single one more question mark. What is meant by engineering mechanics? We have to define the engineering mechanics. The basic physical science. It is a application of laws of mechanism to field problem. Application of laws of mechanisms to field problems is termed as engineering mechanics, that you have to explain here. Or otherwise, you can write it is the main branch of the physical science that deals with the state of rest or state of motion. Then it is called as the engineering mechanics also, you can write. Okay, this is one of the main important point. And then they will ask one more question is whether what is meant by static and dynamics. Whether a body is in a state of rest or body is in a state of motion, then you will call as it is in a state of motion, then it will call as a dynamics. That is one of the main important point. Next we will see one by one. Here, some laws of mechanisms. What are the laws of mechanisms? How we'll get the laws of mechanisms? This also we learn from the starting from the sixth standard onwards. Laws of mechanics: Newton's first law, Newton's second law, and Newton's third law. These are the main famous laws that we had to learn from the sixth standard onwards. And then Newton's law of gravitation, law of transmissibility of forces, and then parallelogram law of forces. These are the main important topics in our engineering mechanics. In that first one, here we'll learn what is meant by Newton's first law. It already all of you know about the Newton's first law. It states that every body that continues in a state of rest, or it is in a state of motion, uniform motion in a straight line, unless it is compelled by the external agency acting on it, there will be some F equals to ma, like that, whatever we are learning. This is nothing but the Newton's first law. This leads the definition of forces as external agency which changes or tends to change the state of rest or uniform motion of the body. Whether the body will be in a static position, that body we want to change from one place to another place, we have to apply some force. Whether the body is in a state of rest, in that rest we are moving the position of that body, that leads to uniform linear motion we are applying here. That is called as the Newton's first law. This one all of you know, I think, first from starting itself onwards. Next, Newton's second law. Here you can observe this one is the first position. Newton's first law, the body will be in a state of rest or it is in a state of moving. We are applying some force, it will be move some position. Okay. In second one, here in first law, what we are learned means every body continues in the state of rest. Each and every body, even if we are in the state of rest of uniform motion, whatever the our load, that will be in a straight line, unless it is compelled to the external agency acting on it. If some other person has to come and has to push us, then only we have to move. Suppose if we are observe any ball or any material will be there, that will be in a state of uniform motion only, that will be in a state of rest only. But whenever we are applying some force and then compelled, then only some external agency will apply, then only it will move. That is the first law. Okay, the definition is nothing but the force as the external agency which changes or tends to change the state of rest or uniform linear motion of the body. This is the first law. And the second law is nothing but, already you know, it states that the rate of change of momentum of the body is directly proportional to the whatever the impressed force, and it takes place in the direction of the force acting on it. Second law is nothing but whatever the force that we are momentum, change in momentum of the body. We are applying some force, that some acceleration, some mass and acceleration we are seeing here. Force is directly proportional to the rate of change of momentum, but momentum is nothing but the, already you know what is meant by momentum. It is nothing but some mass into velocity. Okay. Here force equals to mass into acceleration. That is, force is directly proportional to mass into acceleration. That we had to learn in Newton's second law. Okay, what is the Newton's third law? This one all of you know. These are main famous dialogue for us. There will be equal and every opposite reaction. Every action there is equal and opposite action that we have to apply here. You can observe here, whatever the force we are applying, based on that force only, oppositely there will be another force also will come to us. That will be the whatever the force, each and every action there will be equal and opposite reaction. That will be observed here in this Newton's third law. That is the Newton's third law equation. Newton's first law is whatever the motion, whatever the body will be in a state of rest or in a state of moving, we are applying some force, then only it will move. Second one is that force that will be directly proportional to the mass, and then acceleration, that is the momentum of the body. That momentum equals to mass into acceleration. F is directly proportional to ma. And then in the laws of mechanisms, these are the three laws first you have to observe: Newton's first law, Newton's second law, and Newton's third law. Newton's third law is nothing but every action there will be equal and opposite reaction will be there. That will be our Newton's third law. Now we'll see what is the Newton's mechanism. That is Newton's law of gravitation. This one already we know, according to our acceleration due to gravity, and then gravitational force, how will it be applied, and how Newton's law of gravitation will be there. Here you can observe here there will be two bodies is there. Every body attracts the other body. Okay. The force of attraction between the two bodies is directly proportional to their masses and inversely proportional to the square of their distance. Inversely proportional to the square of the distance between them. That equals to F equals to G into M1, M2. M1 is one mass, another one is M2 is another mass. This will be directly proportional to each other, M1 and M2. And these two are inversely proportional to the distance of their distance between their this distance between them. Okay, square of the distance between them. According to this law of this law, the force of attraction between the bodies of M1 and M2 at a distance of d is given by the equation Newton's law of gravitation. F equals to G is nothing but the gravitational force. F equals to Z into M1 M2 by d square, where G is the constant, that is the proportionality and is known as the constant of gravitation. F equals to G into M1 M2 by d square. This is the main Newton's law of gravitation. These are all the laws of mechanisms. Okay, this is the fourth law. And the fifth law is the law of transmissibility of force. Okay, here you can observe there is a total 6 laws are there. First in laws of mechanisms, Newton's law of first law, Newton's laws of second law, Newton's third law, and then Newton's law of gravitation. And the fourth one is the law of transmissibility of forces, and the fifth one is parallelogram law of forces. Okay, now we'll see the fourth one, law of transmissibility. Law of transmissibility of forces is nothing but according to the law, the state of rest or motion of the rigid body is unaltered if a force acting on the body is replaced by another force of the same magnitude and the same direction, but the acting anywhere on the body along the line of action of the replaced force. Law of transmissibility is nothing but suppose if two persons will be there and two persons wants to move one vehicle, there will be in some same force we are applying, but there will be different magnitude and different direction. Here you can observe here, according to this law, the state of rest or motion of a rigid body is unaltered if a force acting on the body is replaced by the another force. Whatever the force is applying up to now, F1 force is applying, and then now we are replacing the F1 force with the F2 or F3 force, and then based on that force with the same magnitude and same direction, there will be but acting anywhere on the body, whenever it will be top or bottom position along the line of action, and then we are replacing that force, then it will be called as the law of transmissibility. Suppose F1 force is applying at the top, and then that vehicle or that body is moving. We are replacing that F1 force with F2 force. Whatever the force that are applying will be not at top, it will be at bottom. But the same force is applying, same magnitude is applying, same direction is applying. But there will be some replacing of the force. That force will call as the law of transmissibility force. Okay, here you can observe the law of transmissibility of forces can be proved using the law of superposition, which can be started as the action of the given system of forces on a rigid body is not changed by adding or subtracting any other forces in equilibrium. Suppose if you observe here, this is one of the force, whatever the force we are applying here with some force F1 at A, and then after some time we are applying the same for the same material with the same direction, we are applying the another force at F2, but whatever the destination it wants to move, it will reach the same. That the force F1 and F2 will not be any changes. It will not change it by adding or subtracting any forces in equilibrium. Then it is called as the law of transmissibility or law of superposition also will call. This is one of the fourth law. Next we will see the next one, parallelogram law of forces. Why we have to learn about this parallelogram law of forces means, first we learned about the Newton's law. In that Newton's law, we know about the body, whether it is in a state of rest or is it is in a state of motion. Afterwards, we are moving the body, and then immediately what will happen? It will give the opposite reaction. Once it will give the opposite reaction, again what we are doing, law of transmissibility we are doing. We are changing the forces and then we are moving the body and then we are finding the law of transmissibility due to the gravitational force, that is a law of gravitation. These are the 5 laws we had to learn. According to these 5 laws, again we will see parallelogram law of forces. Here what we are observing means, in this parallelogram law of forces, the forces that enable us to determine the single force that called the resultant force, which can be replaced the two forces acting at a point with the same effect as the two forces. Here you can observe P force will be there and Q force will be there, but combination of these two forces will be the resultant forces are. Okay. This law states that if the two forces acting simultaneously, P and Q, all of you observe here, these two forces, P and Q forces, two forces are acting simultaneously on your body, on a point, are representing in the magnitude and direction. Both are representing in magnitude and direction by the two adjacent sides of the parallelogram. Their resultant is represented the magnitude and direction by the diagonal of the parallelogram, which passes through the point of intersection of the two sides, which will be represented as the forces. This one already we learned in 8th or 9th standard, and then in applied mechanics and engineering mechanics and our first year also we learned, and then we done some lab equipments also, lab practicals also we done for this law of parallelogram. In this parallelogram law is nothing but the whether we are applying the two forces from one point. Based on the two forces, there will be one resultant will be there. That resultant will be the diagonal resultant. That will be the same when compared to the P forces, same magnitude and same direction. That force will call as the law of parallelogram of forces. Okay, this is one of the main important law of mechanics. Total 6 laws of mechanics are there. Newton's first law, second law and third law, and then laws of gravitation, and then one laws of transmissibility, and the last one is the parallelogram law. We'll see after learning of these 6 laws, again we'll see triangle law, that is the polygonal law, triangle law and polygonal law of the each and every body. Why we have to learn about this means, whether we are applying some force for any body, there will be different categories will be there. We are applying according to the parallelogram law of forces, or we are applying triangle law of forces or polygonal law of forces, how the body is lifting and how the body is moving, and then with not more forces, how the body is easily carrying from one place to another places. Suppose this all we had to see in our lift conditions, and then whatever cranes, that all we had to observe for this according to these criteria. Okay, next, triangle law of forces. It may stated that there will be two forces acting on a body or represented one after another by the sides of a triangle. Their resultant represents the closing direction. That closing side of the triangle taken from the first point to the last point, then it is called as the triangle law of forces. Suppose if you are taking A point, A to B is one force, and then A to C is one force. Whatever the closing point is, C to B, that force is called as the triangle law of forces. So this is one of the method to closing the resultant. That is the triangle law of forces. Another one is the polygonal law of forces. Here, if a number of concurrent forces that are occurring simultaneously on a body that are represented in magnitude and direction, and then by the sides of the polygon, then then the resultant is represented in magnitude and direction by closing the direction. By closing the closing side of the polygon, taken from one point to the another point, from one point, what was the first point and the last point is called as a polygonal law of forces. These are all the different law of forces that we had to learn here. To know the triangle law and polygonal law, we had to know about the forces, and then we had to know about the different categories here. System of forces. First of all, what is meant by force? Force is nothing but it is defined as the agency which changes or tends to change the position of a rest or uniform motion of the body. That one we call as a force. Okay, force is nothing but it is an agency which changes or tends to change the position of rest or uniform motion of the body is called as a force. Okay. Now we'll see the system of forces. There will be more number of system of forces that we have to learn here. First one is the collinear. Next one is the coplanar forces. Coplanar like forces. Here all of you observe here. Okay, this one is the collinear forces. This collinear forces is all points or all forces will be in one plane and one direction. This will be collinear forces. Here you can observe here coplanar forces. This one will be the coplanar like forces. All are in one direction. Coplanar parallel forces is nothing but the all forces are there, but they will be in opposite direction. Coplanar concurrent forces is all are in one plane but in different directions. Coplanar non-concurrent means there will be not in a one plane and then there will be in different directions. That will be observed here. This one is coplanar non-concurrent forces. Non-coplanar parallel forces is nothing but they are not in a one plane. They are moving in from different planes, but they are all in non-coplanar, but they are in parallel direction. Okay, this one is non-coplanar concurrent forces. That means they are all not in a one plane. They are not in a one direction. Another one is a non-coplanar non-concurrent, not in one plane and then not in one direction. These are all the main different types of the system of forces that we have to learn. This is the main force system. Here you can observe here, whatever according to our diagram, whatever we learn here, according to this diagram, first one is a collinear. Here you can see collinear. What are the main characteristics and then what are the examples of that collinear? Okay. Now we'll see the main characteristics of that collinear. Collinear forces is nothing but the line of action of all the forces act along the same line. That will be called as a collinear forces. You can observe here, this all will be in a same line. The main example is forces on a rope in a tug of war. We will observe there that will be only one rope will be there, but there will be more number of forces in opposite directions. Two sides there will be 10 persons will be there. There will be 10 forces will be there, but that all forces will be on the same line. That are all the collinear forces. The example is forces on a rope in a tug of war. Next one is a coplanar parallel forces. All forces are parallel to each other and the line of action and they are lie in a same plane. If you see the diagram, here you can observe whatever the coplanar forces. All the forces are parallel to each other and lie in a single plane. These are all called as a coplanar parallel forces. Examples are the system of forces acting on a beam that's subjected to a vertical loads, that including the reactions that we'll call as the coplanar forces. Okay, next we'll see coplanar like forces, like parallel forces. All the forces are parallel to each other here, that all lie in a single plane and acting in the same direction. All forces will be in one direction. The main example is weight of a stationary train on a rail when the track is straight. Okay. Whatever the total load will be, the straight lines, here you can observe, all are in same downward direction. If you observe, if you think that, imagine that here it will be a railway track will be there. Whatever the train that will be stopped, that the total load will be on the same direction, in the downward direction, all will be in a straight line. These are all the coplanar like parallel forces. Next one is the coplanar concurrent forces. Here, the line of action of all the forces pass through a single point and the forces lie in the same plane here. The main example for this one is forces on a rod resting against a wall. Here you can observe here. The rod which is resting on the wall. That is a coplanar concurrent forces. Coplanar non-concurrent forces is nothing but the all forces do not meet at one point, but they are meet in a single plane. The main example for this is forces on a ladder resting against a wall when a person stands on a rung which is not at its center of the gravity. Here you can observe the diagram. This one is a coplanar concurrent forces. This one is coplanar non-concurrent forces. This one is a suppose if you think this one is a wall. For that wall, there will be one ladder will be there. That is the one force. But the position, whatever the man standing on that ladder will be the other direction. That all will be the coplanar non-concurrent forces. Okay. Had to think with examples, then it will be easy for you for your while you are telling about the system of forces. First one is you had to remember the example of tug of war. There will be a straight line, that is a collinear. Second one, you had to remember about the collapse. That is coplanar parallel forces. That is a system of forces acting on a beam. That will be including the reactions that you have to know about the coplanar parallel forces. Another one is the coplanar like parallel forces. That is you have to remember about the train. Another one is the coplanar concurrent forces. That is nothing but the whenever we are forces on rod resting against a wall, there will be number of forces on a rod that are resting on the wall. Non-coplanar parallel forces is nothing but the weight of the benches in a classroom. Okay, non-coplanar, but parallel forces. All the forces are parallel to each other, but not in a same plane. These are all example is weight of the bench, weight of the benches in a classroom. There will be not in a one plane, but they are all in parallel forces. Okay, non-coplanar concurrent forces. These are all the forces do not lie in a same plane, but their lines of action will be through a same single point. That is nothing but like our tripod, which we are carrying a camera. 3 points will be a different direction, but the center point, whatever the camera will be there, that will be in a one clip. That is a non-coplanar concurrent forces. Okay. Next one is the non-coplanar non-concurrent forces. All the forces do not lie in the same plane, and their lines of action do not pass through the single point here. Here it is nothing but what we have to think means, for example, it will be the forces acting on a moving bus. What are the forces will be there? What are the moving? The bus is moving from one plane to another plane, and there will be not be a non-concurrent. There will not be a non-coplanar. Not in a single plane, and not all the members will be at single point. Okay, that is one of the main method. This is a total 8 methods, 8 system of forces are there. Collinear forces, coplanar parallel forces, coplanar like parallel forces, coplanar concurrent forces, coplanar non-concurrent forces, non-coplanar parallel forces, non-coplanar concurrent forces, non-coplanar non-concurrent forces. Okay, these are all the main system of forces we have to learn here in this class. Again, for this one, we will see some more problems. Simultaneously, some small bits we will see here in this class. For your, according to our gate preparation, all of you please see here. With answers I kept here. Only single topics, first topic of our, after first topic, we will see the some small definitions. All of you observe here the bits. The term force may be defined as an agent which produces or tends to produce or destroys or to destroy the motion. It's called as a force. Correct or not? Whether it will be agree means you have to write as agree or it will be correct. Okay. Next. Second one. A force which acting on a body may be, a force is acting on any body, what will happen? Okay. It will change its position or the balance the forces already acting on it. It will give rise to the internal stresses in it or all the above. The force, once it is acting means it will change, it will do all the things. Force is doing means it will be change the motion, it will rise the internal stresses, it will balance the section. That all will observe here. That is all of this. Next one. In order to determine the effects of the force acting on a body, we must know what are to determine the effect of the force. What you have to know, whether it is moving the left direction or right direction, like that you have to know. That means we have to know the magnitude of the force. We have to know the line of action, and then we have to know the nature of the force, whether the force is push or pull, like that we have to know all of this. That's why here also it is all the things that you have to know. Then only we will tell about the whether the force is acting on a body in which direction, and then what are the effects. Okay, next one. What are the units of force in SI unit? That is newtons. Okay, please remember this all. Newtons of force is newtons. Units of force is in SI newtons. Okay, 1 kg force is equal to 1 kg equals to 9.81 newtons. Already we know this one in our labs. Okay, if you are unable to remember, you have to listen, and then you have to note down the point, and then you have to remember 1 kg of force equals to 9.8 newtons. Next one, A resultant force is a single force which produces the same effect as produced by the given forces acting on the body. All of you first read that one. A resultant force is a single force. Resultant is, if suppose there will be P force and Q force is there from center O, OP and OQ is there. OR is the resultant. It's a single force which produces the same effect as produced by the all the forces acting on the body. OP and OQ, whatever the forces are acting, whatever the forces are given, that two forces will be combinedly given by the OR force. That is called as the parallelogram of forces. That is a diagonal force. That is true. Okay. The process of finding out the resultant force is known as dash type of forces. The process of finding out the resultant force is called composition of forces, not resolution. Okay. Process of finding out the resultant force. Whatever the center point we are finding, that center resultant force finding is called as the composition of the forces. Okay, next one, the algebraic sum of the resolved parts of a number of forces in a given deflection in a given direction is equal to the resolved part of the resultant force in the direction is called the principle of resolution of forces. Okay, next we will see what is the vectors method. Vector method is also called as the polygonal law of forces. Next, these are all the based on their polygonal law of forces, and then based on the parallelogram law, and then triangulation of law. That based on that all laws, we can observe these all formulas. The resultant of two forces P and Q acting at the same straight line, but the opposite direction is given by P and Q. P is greater than Q. That is, P is 10, Q is 8. Then what is the opposite direction? Opposite direction is P minus Q. You have to think that. Okay. Next one is the resultant of two equal forces P making an angle of theta. Then it will, the equation is 2P cos theta by 2. Okay. Next one is the resultant of two forces equal to P acting at right angle. The answer is square root 2P. The next one is the angle between the two forces when the resultant is maximum and minimum respectively. Then the angle will be 0 degrees and 180 degrees. That is a straight line. Maximum is 180, minimum is 0, like that you have to do it. Next one is the resultant of two parallel forces has the same magnitude, has the same direction. Then the angle between the two forces, same magnitude and same magnitude as either of the forces. Two equal forces of the same magnitude. Then the angle between the two forces will be 120. How will all you have to observe here? Two forces. One is P, another one is Q. Two forces will be there. The magnitude of these two direction is 120 degrees. Okay, that you have to check here. Next one is resultant of two forces P and Q is R. If Q is doubled, then the resultant is perpendicular to P. Then whatever the Q is nothing but the opposite direction, that must be equal to the resultant. Okay, these are all the problems you have to solve. Then only it will be easy for you to know the value. Okay, now we'll solve some more problems here. Then we can know easily. The number of forces acting on a point, then the resultant will be, equation will be square root of resultant R equals to sigma V square plus sigma H square. That is our equation. Here you can observe the forces which meet on one point and their lines of action also lie on the same plane or called as coplanar congruent forces. Okay. I should know about the system of forces, total 8 system of forces, then you can easily able to write these all questions. The forces which do not meet at one point and their lines of action may not meet on the same plane, then it is called as the none of the above. That is, there is a non-congruent, non-coplanar forces, but here that is not there. Non-coplanar, non-congruent. Okay, now we'll see one small problem for today's session. Okay, all of you please note down this one. This is a diagram. One triangle they give. Find the resultant of the force, that is a force system acting on the lamina of equivalent triangular shape shown in figure. This one is the equivalent triangle. This equivalent triangle inside is total 60, 60, 60 degrees will be there. But the forces is given as here at B point, the horizontal force is given as 80 Newton. At C point, at an angle of 30 degrees, they give us 120 Newton. At A, at an angle of 60 degrees, they gave 100 Newton. Okay, for this, we have to find the resultant force. How will find the resultant force? First, we have to take all these in one plane. All this in one plane means first we have to consider whatever the forces in different directions that will be in one single point, that will be whether it will be in horizontal position or in vertical position. First we have to calculate. Okay, can all of you observe here? Summation of horizontal force is equal to 0. That will be first one is 80 degrees, 80 newtons, that whatever the 80 is given. Second one is 100. This 100 will be at an angle of 60 degrees is there. That we have to consider towards horizontal means cos. You have to remember horizontal cos, vertical sine. Okay. 100 cos 60 minus whatever the direction you have to observe here. Based on this direction, these two directions, whether there will be in left side direction or right side direction. Right side directions will be positive, left side directions will be negative. Okay, that's why plus 80 minus 100 into cos 60 minus 120 into cos 30. Okay, had to do all this, then you will get the sigma fx equals to minus 73. This minus is nothing but whatever it may be, that will be in the right side direction. Okay. Next one, Rx equals to 73.92 newtons, we have to find here. Similarly, you have to find summation of vertical forces equal to 0. Then whatever the 80 will be in opposite direction, plus 80 in downward direction. And then this 120 will be also straightly we have to take in this direction, downward direction, 120 sine 30. This will be in opposite direction, that's why minus 100 sine 60, then we will find the Ry value. Once we will get Rx and Ry, then we will find the resultant R equals to square root of sigma h square plus sigma y square. Then we will get the resultant force R equals to 91.19 Newton. Okay, here you can observe here Rx is in left side direction due to negative point, negative value, whatever value you will get. And then this one also in downward direction, this will be in positive direction, that's why sigma y. The combination of these two will get the resultant R. Okay, now you have to find the what is the angle between these two. To find that angle, tan alpha equals to summation of vertical forces divided by summation of horizontal forces, sigma Fy by Fx. Okay, tan alpha equals to sigma Fy by Fx, you have to find. Already we calculated this Fy and Fx, and then we'll get the angle. Angle alpha equals to 35.84 degrees. Okay, let x be the distance from A at which the resultant cuts AC. Here you can observe, we are thinking that at a distance of x, the resultant is cuts the AC. These 2 points will be there. Taking the moment about A, we are taking this one. Taking the moment about A, and then we are writing here, all of you observe here. This one is our resultant, whatever the resultant we find. This one is our angle, and then this one is our total plane. For this plane, we are finding now what is the value of x. This x is cutting the AC value. Okay. Whatever the or x or y. Okay, this one Ry into x minus 80 plus 100 into 60 plus 80 into 50. That is the distances. Here 80 into 100 sine 60 plus 80 into 50 plus 120 into sine 60 into 100. These are all the distances. With distances also they are multiplying. They are finding the total distance. But according to our question here, we ask only the resultant, not the distance. Okay. Here only find the resultant of the force. Only up to R is enough. If suppose they ask what is the resultant, that resultant will be at what placements, you have to find the distance also. Lamina of the distance is the total distance you have to find here. had taken one straight line. In that straight line, we had to find the total x value. That x value had to find. To find the x value, how we find means whatever the values are there, this 80 into 100 sin 60. It will comes to here 80 into 100 sin 60, 80 into 50 plus its total C point is 120 into sin straight point, 120 into sin 30 into 100. Okay, this center point will be only 50. Other 2 points will be multiplied with the whatever the load is acting on that. Then you will get the x value, the total distance. That is one of the methods to find the resultant forces. And then this one is according to our Lami's equation, Lami's theorem. Our Lami's theorem is whatever the force will be divided by the opposite angle, r1 by sin theta, r2 by sin theta, cos theta plus p by sin theta, q by cos theta, or by sine of whatever the opposite direction angle. This one already our formula will be there. According to our Lami's theorem, Lami's equation, we are finding the forces. Okay, these are all the main, this type of questions they will ask for your gate exams. Suppose a roller is there operating some distance and then some force is applying. You have to find the least pull. What is the least force we are applying that to climb the that roller, that ball, whatever the ball is there, that has to be come to the ball. That we have to find according to the our equation, our forces equation. These are all the different problems are there that we will see in the next class. In tomorrow class, again, we will see what are the different types of resultant forces are there. In tomorrow class, what is the resultant force? What are the resolution of forces that we will see in the tomorrow class? Tomorrow, gate class will be from 2 to 4 p.m. All of you be prepared and be ready. Okay, students, thank you, ma. Thank you for today's class. And then tomorrow class, we will see resultant forces. And then another engineering mechanics, another topics will be there. That another topics will be the friction topics we will see. Tomorrow we will complete the engineering mechanics. And Sunday we will see the structural analysis. Thank you.